Good morning and welcome to our Autodesk CAM Options webinar, an overview of what is available from Autodesk. I'm your presenter, Carl van Rooyen. I'm an applications engineer with Micrographics, and my email is carl@mgfx.co.za. The session will be recorded and all participants are muted. You can, however, take advantage of the chat panel to ask any questions, and I'll answer these either as I see them or at the end during the Q&A session. So on the agenda for today, we'll be looking at various CAM options, CAM solutions that Autodesk has to offer. I've grouped the software to fall into what I believe their target markets are and the level of functionality that is offered by each package. We'll start off with Fusion 360 and Inventor CAM, and then we'll move on to Fusion 360 with its manufacturing extensions, and then FeatureCAM and PowerMill as our last two options we'll look at. And lastly, we'll close with a summary and Q&A. For this presentation, I am going to concentrate mainly on the CAM solutions that were listed, and I will briefly mention a few things about additive manufacturing, but this is not the focus of the webinar. The solutions on offer from Autodesk that we'll be looking at today are Fusion 360, which is a CAD-CAM package that can be purchased with or without the manufacturing extensions. And your purchase of Fusion 360 also includes HSMworks for SolidWorks. So if you're a SolidWorks user and you are looking for a Autodesk CAM solution, you would need to purchase Fusion 360 to get that HSMworks. The next option is Inventor CAM, that is purchased as part of the product design and manufacturing collection. And it integrates CAM functionality directly into Inventor, so you can design inside of Inventor and then change the environment to the CAM environment and continue on with your CAM programming. Then the last two that we'll look at are FeatureCAM and PowerMill. These are two standalone CAM packages, and you would generally import a completed part design into these before you start your CAM programming. So firstly, we'll look at Fusion 360, HSMworks, and Inventor CAM. I've grouped these packages together as they basically share the same core set of commands and are nearly identical in their features and functionality. There are one or two small differences, but we'll see that as we move along. Fusion 360 is a good product for hobbyists who want to use it in their personal capacity and startups because of its price point and its license options. So it is the sort of entry level as far as price point goes, and it gives you quite a good set of features. Both products, Fusion 360 and Inventor CAM, are well suited for general purpose machine shops or manufacturers who have basic manufacturing requirements, or who want to in-house machining that may be done by an external supplier. Maybe you've had some quality control issues and you want to take control of more of your process. These packages are a good starting point for that. They'll also be suitable for established manufacturers with basic machining requirements. Maybe you're changing over from a different package over to Autodesk to streamline your product offerings. Then for this presentation, I have defined basic machining requirements as anything up to 5-axis machining of simple parts, where you're going to have limited user control over tool parts, where limited control over tool parts is acceptable. As previously mentioned, Fusion 360, HSMworks, and Inventor CAM all share the same basic functionality. I say basic, but remember, this does include up to 5-axis machining. So these packages offer Autodesk's entry CAM functionality, and they are well suited for most CAM users in the general manufacturing market. This functionality includes 2-axis cutting for laser, plasma, and waterjet. You can see an example here on the right-hand side. That bottom image showing a chair being waterjet cut from material. It also offers 3-axis milling features. For example, at the top there, we've got that Fusion logo that's being machined. And this also expands to 3+2-axis milling and simultaneous 5-axis for more complicated parts that you can produce with less setups if you have a machine that's capable of 5-axis. It can also do 4th-axis milling for cylindrical parts. So if you have a 3-axis machine fitted with a 4th-axis, you can do cylindrical parts. Unfortunately, you are limited to wrapping a toolpath around that cylinder. So you would need to be dealing with purely cylindrical parts for that 4th-axis milling. These packages also offer turning for use in conventional CNC turning centers, including centers that have a secondary spindle. So these packages can handle passing that stock from the first spindle to the second spindle for subsequent back-end operations. They also include WCS probing, or World Coordinate System probing, to locate your stock on the machine and then zero your machine according to the position of the stock. And in Fusion 360, there's also an option for additive manufacturing for fused filament fabrication, or FFF. These are basically your 3D printers that most people would know, where you have your filament and that's extruded in layers onto the machine. So stock out of the box, Fusion 360 can allow you to output code directly for those types of printers. Now, that rounds off the, sort of the market for Inventor and Fusion 360 and HSM, and then we can look at moving on to Fusion 360 with the manufacturing extensions. So we're moving up a tier to some slightly more, just features that are slightly better. So moving up that tier to Fusion 360 with the unlocked manufacturing extensions, this increases the functionality of Fusion 360's manufacturing environment and is available either as a monthly or yearly purchase. So when you purchase your Fusion 360, you'll have an option to purchase it with extensions for the year, or you could, on an as-needed basis, purchase that extension for a month. So the target market for this, I see it being companies that would benefit from this when they need to expand their functionality on an ad hoc basis. So let's say for a specific project or for a month or two, the company gets a project in and they realize, hold on, I need to expand on my CAM functionality. They can then unlock or purchase those extensions for a month and make use of what they need from it. Or it could be an established manufacturer that just needs to bolster their functionality on a continuous basis, but they're not quite ready to take that leap into specialized CAM software. I would even suggest that the extension could be unlocked to generate a production-ready CNC program. This program can be generated. You create your CNC file that can be put onto the machine in production and run through in production, and the extension can be left to expire if it is not needed anymore. If any changes are required on that production CNC run, then the extension can be unlocked. Those tweaks can be made to that program or to that the part, and the new NC file or the new program generated and put back into production. And once again, if the extension is not required, it can just be left to expire at the end of the 30 days. So that's kind of the target market that I see for the Fusion 360 users who would want to unlock manufacturing extensions. And what we'll do is we will look at the manufacturing extensions or the features that are unlocked with those manufacturing extensions. So the functionality here. So what you get when you're purchasing these extensions, you're getting a small taste of what is in FeatureCAM and PowerMill, with the availability or the unlocking of the following strategies. You get steep and shallow with fifth axis collision avoidance. You unlock hole recognition, the ability to trim toolpaths, perform rotary machining on a fourth axis, probe geometry, inspect surface, and you also unlock additive metal powder bed fusion. So when unlocking the manufacturing extensions, you unlock all of these features. There's no picking and choosing of which of these features you want to unlock or not. You spend your credits, you unlock your features, you get all of these available to you. The next few slides that I'm going to go through will be a short overview of most of these strategies. So Fusion 360 with manufacturing extensions, you unlock steep and shallow, and the steep and shallow will scan the part and apply the appropriate milling strategies to both steep areas and shallow areas. So this is controlled by the angle of the surface, and it can be adjusted to your preference. The animation on the right-hand side here that I've just brought up will show you the result. So having a look at that animation, when it shows number 1 in that circle, that shows the steep areas that have been picked up by the tool, by the steep and shallow operation. So it will apply one type of toolpath to that steep area. Then number 2, showing there, will apply a shallow machining. In this case, it looks like a spiral or a scallop to that shallow area. Those 2 areas are then combined to step number 3, which is this one here, that combines both steep and shallow machining strategies into one smooth toolpath. Your steep and shallow strategy also has options to reduce cusps at the apex of those toolpaths, and there are a couple of extra options within there that are all editable by the user. You then get your hole recognition. Hole recognition allows you to recognize holes based on predefined parameters that the user inputs. So the hole recognition takes away the need for you to manually go and select each hole. And on top of that, it also takes away the need to select the required drill diameter. So you essentially open up the hole recognition wizard, you select the tool axis that you want to either limit your hole recognition to, or you can select to recognize all holes on that feature, on that part, and it will find all the holes and select the required hole diameters and tools for machining that. Another option is the trim toolpath. This allows you to delete unwanted toolpath segments with links and repairs to the remaining toolpaths being automatic. So you could delete a portion of toolpath that you don't want, and the program will automatically relink the remaining pieces together. And the last one for this slide is the Rotary Strategy. Now, Rotary is different to the wrap toolpath because the Rotary Strategy is for milling non-cylindrical shapes. So it allows you to use your fourth axis and machine non-cylindrical shapes with also more control over the toolpath for things like the direction. Do you want to machine around the fourth axis, as we see in the image on the right-hand side, or do you want to machine along the length of that fourth axis? And this also gives you control over the direction and the limits and also the position of the tip of the tool. So we can see here in the image that fourth axis rotary part being machined. On this next slide, we look at a couple of the other features. We have probe geometry. This can be used for in-process part verification. So while your part is in the machine, you are able to probe the position of the part and then feed back that information to the machine. You could probe features. Look at the image on the right-hand side there. You can probe either the position of the part, feedback that information, even information like tool wear. You can see that if the part is larger than it should be, that information can be fed back into the machine and the machine can adjust for tool wear. If the part is completely out of spec, you could even have it stop the machine after that probe cycle. The next option there is inspect surface. Inspect surface will allow you to probe multiple points on the machined component, and this will then generate a report. This report can be imported back into the model for part verification. So essentially, when that part is probed, we can see on the right-hand side, there are 3 points that are probed, and each point is a different color. That report that is pulled back is compared with the original model in CAD. That CAD and the real-life dimensions that are measured show comparison. You can see that the green dot there, that is within the specified tolerance. The red dot will be below tolerance, so you've machined away too much material. And the blue dot is above tolerance, which means there's still more material that needs to be machined away from the part. So you can do quality control while the part is still in the machine. There's no need to remove the part from the machine. There's no need to remove the part out of the machine and then do quality control, and if there are any issues, putting the part back into the machine. So this speeds up the verification process of the part. The last feature that is unlocked that I'm going to cover is the addition of the additive portion of the extension, which adds the ability to use metal powder bed fusion, or MPBF, within your part setup. So this extends your 3D printing capabilities to your 3D printing manufacturing capabilities to metal 3D printed parts. I won't go too much into that, but the extension does then allow you to do metal sintering or laser type 3D printing. So moving away from the sort of entry level and mid-range CAM packages, we now move on to Autodesk. So what I would say is Autodesk's top CAM offerings. We're looking at FeatureCAM and PowerMill. These are two products that are available for purchase separately, and they run as standalone CAM packages. So you could have any design package, but if you find that FeatureCAM or PowerMill fit your requirements, they satisfy your needs, these can be purchased as standalone CAM packages. So these packages offer more features and control over machining. And these make them more suitable for high-end machine shops that have to comply to stringent quality and even time requirements. I see these environments being machine shops who require the highest level of control and automation. So the types of industries that we would see this being used in would be your tool and die makers, who require a very high quality surface finish, let's say for plastic injection molding. You want a good surface finish there so that your molded part is nice and smooth, it is perfect. You don't want to have to go in there after the fact and polish out a lot of detail. So tool and die makers can make use of these offerings. Mass production facilities as well. They may require reduced programming times due to the amount of product that they have to program and put into production. They may need to optimize the tool paths to reduce machining times. You can imagine if you're producing 1,000 parts a day, a second, 2 seconds per part is going to make a huge difference at the end of the day. So tool paths generated by FeatureCAM and PowerMill can be a lot more efficient than those generated by Fusion 360 or Inventor CAM. And this can be extended to manufacturing concerns that require complex machining tasks with equipment such as Swift lathes, which can have multiple operations happening at once. We even operations that make use of industrial robots to complete tasks such as milling of large forms or carrying out additive manufacturing. So these programs are jam-packed with more features and control. So I've broken down these features. I want to highlight for each package into a few slides. So we'll start off with FeatureCAM and its functionality. So FeatureCAM has your traditional milling options up to 5-axis simultaneous, but it also accommodates mill turn, Swift lathe, and wire EDM. And although I make that statement that 3 to 5-axis machining comes with a lot more control and options and automation than you would have versus the previously covered packages like Fusion and Inventor CAM. Other features that will be covered more in depth in the next few slides include things like feature recognition, multi-channel synchronization that would come in with your mill turn centers or possibly even your Swiss lathes, feeds and speeds, setup of feeds and speeds, machine attributes, as well as machine simulation. So starting with the biggest time savers within FeatureCAM is the feature recognition option. And as the name implies, FeatureCAM, it's got that feature recognition. So you would import your model. It allows you to import your model and goes through or step through a wizard. This wizard automatically recognizes features on the imported geometry. The software then automatically applies the appropriate machining strategies for both roughing and finishing the features. So if we look at the image on the right-hand side here, it shows a list of recognized features that you can have operations applied to. So if we look at the list there, select features for setup 1. There's face 01, hole 01, all the way down to hole 4. And then multiple sides, side 1 down to side 5. And we can scroll down further on there. If I jump back to this type of setup in Fusion, you would have to manually go and pick each of those holes. And for the pockets, you'd have to go and pick the base of each pocket to machine those pockets. And in this case, the program through the wizard has automatically picked up those features. And what it will do is it will choose the best operation to machine that feature, but it will also choose or select the best tools for that, for milling that feature. So it will take into consideration internal radii. and choose a tool that will suit for machining into that corner and fitting that radius. Something like the pocket that we see just below the dialog box, we'll see that it also has a radius at the bottom. The correct tool will also be chosen to machine that bottom radius on the component. Now, all the settings that are chosen throughout the process of going through the wizard are customizable by the user. In the case where the user is not happy with what was automatically chosen, or if the particular part has special requirements that don't fit the sort of automation process, but the user can go ahead and choose settings on an as-needed basis. Then if you're working with a mill-turn center that has multiple tool posts and a sub-spindle, you can take advantage of FeatureCAM's multi-channel synchronization. So we can see there on the right-hand side, that is an image of what the synchronization looks like when you're setting it up. Basically, it allows you to choose at which point in the process of machining you can have both tool posts acting on the workpiece. So these synchronization points, we'll see each red line in the model there is essentially a synchronization point, or sorry, each red line in the table in the image represents a synchronization point. These can be done automatically or by the use of drag and drop. So you could pick features, you can pick operations in that list and drag them and drop them to change where they are synchronized. And if we have a look at the first synchronization there, turn 1 rough tool post 1 and turn 1 rough tool post 2, we're essentially turning a part from using tool post 1, possibly from the top of the part, and tool post 2, maybe machining on the bottom of the part. And as the part spins, each of those tool posts is removing material at different depths to achieve the final roughed finish, or to achieve the final roughed part. And then we see tool post 1 or P1, we're doing then the turn 1 finish and then drill. Once again, there's a synchronization. There's machining happening from the top of the component and from the bottom of the component, where those pockets, pocket 1 and pocket 2, are being roughed, finished, roughed, and then sides are being roughed and sides are being finished. So multiple operations are happening at the same time, essentially halving your machining time for those operations. If there wasn't synchronization, let's say pocket 1 rough pass, those 4 operations from there down to side 1 finish would have to happen. The part would turn around, and then the next 4 to the right would have to be done. So synchronization saves a lot of time. Then looking at machining attributes within FeatureCAM, this allows you to configure preferred settings for a particular machine. So what this means is you can have various predefined machine attribute configurations set up. If you have a machine shop with 6 machines and you have 6 different machines, you can have 6 different machine attribute configurations. And you can essentially configure settings for drilling, milling, facing, and more. We can see on the right-hand side an image showing the machine attributes. And I have the milling option selected. And on the right-hand side of that, we see that there are options to choose the milling type. You can use climb mill or conventional if you unchecked it. There is roughing cutter compensation, finish cutter compensation. You can go ahead and set those parameters for that machining attribute setup, and you can save this. So this allows you to post a program to run on a specific machine and have the machining parameters set to suit that machine. This way you can optimize the work being done on the machine to suit its capabilities. So this will go down to, let's say, things like the machine power, the strength of the spindle, the actual rigidity of the machine itself, possibly even the tools available within that machine. And the next one we're looking at here is feeds and speeds. Your feeds and speeds can be predefined according to various parameters or properties. These properties can include the material properties, such as its hardness. So in the image on the right-hand side here, we have aluminium. When setting up your stock, you have the option to choose the material as well as setting a hardness value for that material. Other properties such as your cutter material, or material grade and coating, you can see on the right-hand side here. The tool grade is carbide. For milling, your tool may have a coating on that. So it could be a high-speed steel cutter with a carbide coating, and your feeds and speeds can be set for that specific cutter type. So these are predefined by the user, and then when you set up your operations, FeatureCAM then selects the appropriate feeds and speeds. So these are just a few of the features that you'll find in FeatureCAM. Next, we will look at PowerMill. So PowerMill's functionality will have some overlap with FeatureCAM. However, it has a much larger suite of machine types it can program for. So these features, once again, include 3-axis, all the way up to 5-axis simultaneous machining, but you can also include auto tool tilting and collision avoidance, as well as your in-process surface probing. So there's a lot of overlap there. But what PowerMill gives you is it offers tools for specialized industrial solutions. So here you're really looking at specialist environments. You're looking at offline programming of industrial robots and electrode manufacturing for EDM, EDM being electrode discharge machining, and also operations for machining of Blisks and Impellers. So to go a little bit more in depth into those features, we'll look at a closer look at specifically the multi-axis features that you have access to and what extra control they give you. So the first one is auto tool tilting, and auto tool tilting will turn your 3+2 axis machining into fully fledged 5-axis simultaneous machining. What this means is that you can have all 5 axes of your machine working at the same time to give your tool the best orientation possible for machining. So when you enable the axis tilting, you're also able to set the material clearance for the tool holder and assembly to avoid any collisions. So we can see the image on the right-hand side there showing a collision. Another part of the 5-axis strategies is collision avoidance, which allows you to generate your tool parts even if there are collisions, and then tweak portions of it to adjust tool orientation to avoid collisions. So this image on the right-hand side shows handles linked to the actual milling head, to the machine spindle itself. And you can dynamically, within PowerMill, click on those arrows and rotate the machine head into a better position. So in this case here, it looks like the joint on the right-hand side here for the spindle, that joint here, is colliding with the part. And so what you could do is click on that arrow and grab it and pull that axis over and change the orientation. If we go to the next image here, we can see that the orientation of the head has been rotated around. I'll actually just flip back and forth between the two. We can see here that this arm at the back is coming down behind the part. It has been moved over to the right to clear the part, and the spindle has then been tilted over as well. So you can review your simulation and tweak the machine motion as required by directly dragging on that handle, on those handles, to change the orientation. And this enhanced control is improved by allowing you to actually go into your fifth axis strategy, your toolpath, and select portions of that toolpath and adjust the parameters for it. You can adjust the approach angle or approach direction for the tool, and you can change the specific settings like your lean and lead angles for that portion of the toolpath. You don't have to change it for the entire toolpath. And this allows for that enhanced control over 5-axis machining. Then lastly, we've already had a look at in-process surface probing, like I mentioned, with the Fusion 360 manufacturing extensions. It brings some of these features from PowerMill and FeatureCAM. So in this case, in-process surface probing started in PowerMill can be unlocked in those Fusion 360 extensions. But here, once again, just to reiterate the fact, you can also achieve that in-process part verification with surface probing to check the part quality and tolerances within the part. And this is essentially set up by selecting portions of the surface, and the next slide will show this, portions of the surface or points on the surface that can be probed. So if I go to the next slide here, the next image, we can see that there are control points, and the probe will go and touch down on each of those points while the part is still in the machine. So we haven't had to take the part out the machine. So those points are probed, and that information is fed back into a report file that can be viewed in various formats, and you can then have a look at that. If you have PowerMill, or should I say, if you have purchased PowerInspect, those results can be imported into PowerInspect, and PowerInspect can then also be used to for further processing of those results. That processing could be generating reports for quality assurance purposes. Then moving on, the last thing for us to look at is a few of these specialized tool sets within PowerMill. So these include the ability to do offline programming of industrial robots. So if we have a look on the right-hand side of that image, there is an industrial robot with a spindle attached to it for machining. So it is actually machining a figurine, looks like a figurine from computer game Halo. That could be a giant block of foam, which is then machined by that industrial robot. And so you can do the offline programming of this industrial robot also using those handles where you can click and drag and move that robot into different positions for the various machining or various portions of the toolpath. This offline programming supports up to 18 axes for larger build volumes. If we look at this robot as it's set up here, let's assume that that is a 6-axis robot with the turntable that the foam block is standing on being the 7th axis. So you could have, let's say, 2 to 3 robots in one single cell performing all the machining functions. And the support for 18 axes gives you the ability for large build volumes. That can include your rotary bed, as we see here. It could even be a linear bed that the robot itself moves along, and even adds the possibility for you to hold your material and manipulate the workpiece with another robot. So you could actually have one robot moving the workpiece and the second robot rotating, or a second robot machining that workpiece while it rotates. The next one here is the creation of EDM electrodes. So I mentioned that electrode discharge machining. We have the ability to generate the models for these electrodes using PowerShape, and then PowerMill has a electrode wizard, which then allows you to use that generated electrode for creating the modeling and then actually machining of the electrode. These electrodes are then used as tools for actually using the electro discharge machining for removing that required shape from your stock. So just to go through that again, PowerMill has, or you would use PowerShape to generate the model of the electrode. There are specific wizards for extracting the required electrode shape and properties, and those properties and shape are then used in PowerMill electrode wizard for generating the toolpath or the machining operation for that electrode. Then last one to cover is the Blisk and Impeller machining. So there are roughing and finishing toolpaths that are specifically tailored for Blisk and Impeller machining. And these have been built into a toolpath wizard that allows you to select geometry on that Blisk, and it will then generate the machining process. And these are generally 5-axis machining processes that need to be very accurate to generate turbine blades. And so this gives you a much easier way of generating that complex shape that is required. So in summary, we have the various levels or tiers of package, starting at the top with your basic requirements and then going down as your requirements change. So as mentioned, if you're a startup or you have simple machining requirements, or you don't need the ultimate level of control over your toolpaths and machining, then Fusion 360, HSMworks, and Inventor CAM will do the trick. If you need to have a slight bit more automation, you need a little bit more automation in your process, a little bit more control in your programming workflow, but you're not quite satisfied with the features from Fusion 360 or Inventor CAM, then in Fusion 360, you could add on the manufacturing extension. So that's kind of the mid-level, giving you that extra little bit of control. Then lastly, if you need the ultimate control, you need that specialized program, and you need a good surface finish, consistent quality, automation through the process, which will give you repeatability, then FeatureCAM and PowerMill. FeatureCAM or PowerMill would be one of your options to go with. Like I said, PowerMill gives you a lot more advanced options when it comes to industrial robots, and also one thing I didn't mention is on the industrial robots, it could be for subtractive or even additive options. So we've seen lots of videos of industrial robots with a welding torch on the head to essentially weld and 3D print metal from a, like I said, 3D printing with an industrial robot using a welder to generate that material. So those would be sort of the 3 tiers that I kind of position the products into, and who would be the target markets for those. And in summary, just to close it off, we have the last slide here, which shows a comparison matrix. Unfortunately, don't be fooled when you see a matrix like this and there are features that are shared across programs. If I have a look and I see 5-axis positional or 5-axis simultaneous, we see that, okay, great, Fusion 360 all the way up to PowerMill can do that. However, Fusion 360 may not have all the controls and all the options available that you could have in FeatureCAM or PowerMill. You may not have that level of control that you can get with those specialized packages. So in the list here, we have Fusion 360 with all of its available features, HSMworks, Inventor CAM. So there we should see a lot of overlap with the available features here. One thing to note, Fusion 360, these features that are highlighted include features from the extensions as well. Then one package that I did not include in this presentation is TrueNest. That is the last one here on the list. It is also a standalone package. It is used for specialized package used for linear, so 1D and 2D nesting. So it allows you to nest bar or sheet stock, and it therefore works with cutting of that stock, and it also has stock control capabilities. So if you produce a lot of bar stock, like round bar, square tubing, angle iron, you need to cut a lot of that down to size. TrueNest can nest that into linear nests for you, or even sheet metal. It can nest so you can use the optimal amount of material on your sheets. And it also has stock control capabilities and ties in with your ERP to control how much stock you have left, and also control of dropouts, the smaller pieces that are cut that are not used or supplied. Yeah, so in summary, that's just closing off to show the various features. I will move on to any questions, Q&A. I see none have come through on the chat. I will give a few minutes just for any questions to come through. If not, we will then stop the recording. Okay, I don't see any questions coming through. Thank you for sitting through the presentation, watching through the presentation. I hope you've learned something. And yeah, once again, just to sum up, Carl van Rooyen, work for Micrographics as an application engineer. And up on screen right now, we have our contact details for our 4 offices: Johannesburg, Cape Town, Port Elizabeth, and Durban. I am based in the Port Elizabeth office. Once again, thank you so much, and enjoy the rest of your day. Okay, recording's stopped. Hmm.